In Lab 2 of Physics 2211, we focused on the motion of a falling object. The purpose of this lab is to observe the motion of a falling object and analyzing it with tracker to determine the object's position and corresponding time. We will then create two computational models, one that considers the force of drag on the object and one that does not. The computational models will provide predicted data that will then be compared to the observed data. Important concepts in this lab are gravitational force, Newton's second law, and drag. Gravitational force is the force that acts on an object when it is attracted to another object. Newton's second law states that the net force of an object is the change in momentum over the change in time. Drag is the force that acts in the opposite direction of gravitational force. These are some important formulas that we will use throughout the experiment. The force of gravity is equivalent to the negative product of mass and gravity. The net force is equal to the change in momentum over the change in time. The force of drag is equal to the product of the drag coefficient, which is denoted by b, and the magnitude of the velocity squared. To observe the motion of a falling object, we drop the glue stick from a height of approximately 1 meter. The system is the glue stick, and the surroundings are everything else. For this lab, we can assume that motion is only present in the y-axis. As you can see with the green arrow, drag acts in the opposite direction of gravitational force, which is shown with the red arrow. Here is a video tracker analyzing the video of the glue stick falling and recording its position and corresponding time. This is the data that we will use for our observed and predicted models. The mass of the glue stick is approximately 0.022 kilograms. The rest of the data was collected by tracker. Since we are assuming that there is only motion in the y-axis, we can ignore the tracker data for movement in the x-axis and set it to 0. To create the computational models, we can use the starter code provided and substitute in our values. For our model that does not consider drag, the drag coefficient will remain 0. We must also add the updated formulas of both velocity and position into our code. Here is another image of our substituted values in the code. Running the program gives us these results. For the computational model that considers drag force, we need to set b equal to the drag coefficient, which is 0.0737. We also need to add the formulas of gravitational force and drag into our code. Running the program provides these results. This graph compares the tracker data with both computational models. With drag considered, the glue stick would have a smaller change in position compared to the other two models. This makes sense as drag is a force that acts in the opposite direction of gravitational force. Following that same thought, it also makes sense for the computational data that does not consider drag to have the largest change in position. Some possible experimental errors would be inaccurate tracking due to the glue stick becoming blurry throughout the video and poor camera alignment. There may have also been rounding errors during calculations, specifically when finding the drag coefficient. Terminal velocity occurs when an object reaches its maximum velocity. When that happens, the velocity of the object will remain constant. This can be seen in the computational model that considers drag. In its velocity versus time graph, you can see the velocity begin to stop changing. Throwing the object downward would only increase the initial velocity of the object. Since the mass of the object is the same, the terminal velocity will also remain the same. However, the object would reach terminal velocity at a much faster rate than it normally would have.